All right, so today we will do the same thing that we did in the previous class, except now we're gonna work with the word problems. So this will kind of like show you why is it that we solve equations, because it helps us model situations. So there are some interesting questions in here. That will hopefully give life to what we did in the previous class, because otherwise it's kind of like long and maybe not so interesting to some of you. Okay, so but before we start with word problems, I'm just gonna talk about how to solve some of the equations that might be somewhat challenging. Okay, so these two questions are taken from your textbook. It's question 5 from your textbook. I didn't assign this as homework, but what I'm going to do is I'm not going to solve this. I'm just going to tell you how you would go about solving these questions. Okay, so here the big problem is this denominator, which is 8. No one likes to work with fractions because they're um, when you do algebra with fractions, it's like a lot more time consuming. Okay, so one thing that you should do is whenever you have an equation like this, what I would do is I would just multiply the whole equation, the top equation by 8. Okay, I'm just going to multiply this by 8. Why 8? Because I need to get rid of this denominator. Okay, so when you multiply the whole equation by 8, so the y will become 8y, minus 1 will become minus 8, and then minus 7 over 8 will just become minus 7 x. Okay, so now this will become your top equation. Now, I would go with substitution, okay? I would go with substitution, but I'm not going to solve for y in the top equation. Why? Because if I solve for y, then I'm going to have to divide by 8, right, to get y all by itself. So that wouldn't be a wise thing to do. But here, but the coefficient of my y is 1. So solving for y will be much easier because I won't have any fractions to worry about. Okay, so if I solve for y in this equation, all I have to do is just move this 3x squared to the other side. So that means y will equal to minus 3x squared, right, plus 8x minus 1. Now I can plug this y value, right, and now I can plug this y value into my top equation, okay, and then solve that quadratic equation. And in some instances, you might have to use the quadratic formula, right, because factoring will only work when your solutions are like nice numbers, okay? But when you have decimals and fractions, like ugly fractions as your solution, then factoring will not help you. Okay, so you'll have to use that quadratic formula. Remember I'm going to show that to you in the video a little later, but it's the minus b plus and minus b squared, that one. Okay, so this is how I would do the first question. First, multiply by 8 to get rid of this numerator, and then understand that in this equation, it makes no sense for me to solve for y, because if I do, I'm gonna have to divide by 8, and then that will result in fractions. Okay, so I'd rather just solve for y in my equation down here, which is what I did, and then plug this y value into my first equation. Okay, so that's the logic. Now the second equation will actually show you why the technique of elimination is actually important. Okay, so this one, you see both my y terms have a coefficient, so it doesn't matter um, which equation I use and solve for y. I would probably use the second equation if I really want to use substitution, because dividing by 2 is much better than dividing by 3. Okay, dividing by 3 gives you ugly decimal values, but dividing by 2, you can kind of get away with it. So you could use substitution, but it will force you to um, work with decimals. Okay, so if I solve for y in this equation, then I'm gonna get 2y is equals to minus 3x squared plus 4, and then I will be forced to divide by 2, divide by 2. So y will equals to minus 1.5x squared um, plus, plus 4, okay? And then I can substitute this y value into my first equation. So that's one way of doing it, but you see, you cannot really avoid decimals, okay? So in this situation, the best technique actually is the technique of elimination, okay? So this is where elimination will come in handy. Now, if I subtract the two equations, it's not going to work because if I subtract now 3 minus 2 will give me y, right? 1y or y, right? So it's not going to work. But it's really hard to figure out what you need to multiply this equation by to get 3, right? Because you can't, like 2 and then you get 4, right? So it doesn't really work. So in this case, you have to kind of like, find the common denominator if you want. Okay, a number that divides both 3 and 2. So that number is 6. Okay, that's what you should be aiming for. So what I'm going to do is, what you would have to do, I guess, is to multiply the top equation by 2, because 3y times 2 will give me 6y, and multiply the bottom equation by 3. Okay, so because 2y times 3 will also give me 6y. Okay, and then subtract the two equations. Okay, so let's multiply this out. So that means the top equation, right? The top equation will become 8, because I'm multiplying by 2, x squared plus 6y plus, sorry, not plus, is equals to 2. And then my bottom equation will become, the bottom equation I'm multiplying by 3, so 9x squared plus 6y is equals to 12. And then subtract the 2, okay? Subtract the 2. So the x squared and 9, right? So that will give me minus x squared. The 6y and 6y will cancel, which is what I want. So then you get x squared minus x squared is equals to minus 2 times 12. So that's minus 10. Okay. And you see, elimination made this very easy for me. And basically, now I can actually solve for x, right? So this means that x squared is equals to 10. So that means that x has to equals to plus and minus square root of 10. Okay, so this is somewhat of an ugly solution, but had you used a substitution to solve this equation, it would have been a lot longer. Okay, so elimination is powerful, as annoying as you might find it. In some instances, is very powerful. And I guess one way to identify when to use elimination is when you have when you can't really solve for y, right? Because you have coefficients on top and at the bottom. Okay, that means that if you do solve for y, you're gonna run into fractions and decimals. So elimination would be the best way of doing it. Okay, I'm just gonna quickly check my work. So when you multiply by 2, you get 8, 6, and 2, and then here you get 9, 6, and 12. So you get minus 1, and then yeah. So again, I'm not going to finish this off. I'm just showing you when it makes sense to use which technique. So here I would go with elimination, okay? And here I would go with substitution. But before substitution, and then before I use substitution, I'm actually going to multiply the top equation by 8, which is what I did over here, so that I can get rid of my denominator. Okay, because when you work with fractions, it's very time consuming. Okay, and again, right at this level, you have to not only finish your test on not only do you need to understand how to do the questions, but you need to finish those questions within a certain time frame, right? So this is my way of showing you how to save some time on a test. Okay, so word problems, right? So again, I'm not going to read this because it's too long, but basically what's happening is that you have this cargo plane that's dropping off a crate. So if you graph the first function in red, it looks something like this. Sorry, it's a quadratic function, so something like that. Actually, no. I would assume this is this is my P and Q, because remember in this equation P is 0 and Q is 700, and then this is your maximum, so your function is just decreasing this way. But then there's another function, the linear one, which starts off at 650 and it's probably doing something like this. Okay, so this is how the cargo will drop. Okay, I'm going to do this in purple for you. So the cargo will drop like this because at first it's dropping off in a free fall. Okay, so it's just falling like this. And at this intersection point, the parachute gets open and then it starts falling, but like slowly, right? Much slowly, so gradually. So this is basically the trajectory of the cargo. Okay. So what we are interested in is this point of intersection. Okay, so basically, when is this quadratic function equals to this linear function in blue? Okay, and both of them are expressed in terms of h. So I would go with a comparison, right? I know that this, if you want, let me just do this down here. So h in red should equals to the h in blue. Okay, so the h in blue, what do I mean by that? So remember, there's two functions, right? One of them, so this one is given to you in red. Okay, so this is what the trajectory of the cargo out of the crate looked like. And then down here, this is what the trajectory of the crate will look like once you open the parachute. But how do you find the point of intersection? Well, it has to be the point where this linear equation is equal to this quadratic equation. Okay, so in this case, I'm just going to equal the two h's together. And this is what we call comparison, right? This is what we call comparison. I'm actually going to do this because it will help me see the equation up there. So the equation is minus 4.9 t squared plus 700. Okay, this quadratic function, I want this to equal to my linear function, which is minus 5t plus 650. Okay, now I'm just going to remove that. So how do you solve this? Well, just move everything over. Okay, so I'm just gonna, again, you could just move it over, right? Which is what I do, and then change the sign. Or you could just do the opposite, which some students like to do, which is, I guess, what I'm gonna do just because of you. So plus 5t, plus 5t, there's nothing to combine this with, and then minus 650. So these guys will just disappear, which leaves me with minus 4.9 t squared plus 5t plus 50 is equals to 0. Okay, now in this case, because you have a decimal, don't even bother using the factoring method. Okay, so the factoring method always only works when you have whole numbers, because now when you're going to multiply 4.9 and 500, like this is not where factoring will not work over here. Okay, so so in your textbook, I think what they have is okay, they moved it over to the other side, which is fine. I think they moved these guys up there instead of moving them over here. Again, it's the same thing. So what I'm going to do is, just to be consistent with the textbook, I'm just going to multiply the whole thing by minus 1. Okay, so this will become 4.9 t squared minus 5t, and then minus, sorry, this should be 50, minus 50 is equals to 0. Okay, so this is what your textbook has, and they're using this formula. And again, did I tell you the page number? Yeah, so this is on page 445, 446. So they're gonna solve for t using this formula: minus b plus and minus b squared minus 4ac and square root, and then you divide this by 2a. So plug in the values, guys. Just be careful, right? Um, so this is my A coefficient, right? So maybe I'm just going to write this down for you. So A is equals to 4.9, B is equals to minus 5, right? Carry the sign with you. And C is equals to minus 50. Okay, so make sure you're carrying the sign. And I plug in your values, and then when you do, okay, so T1 will equals to 3.745, and T2 will equals to minus 2.724. Now, because this is a word problem, what happens is, when you have a word problem, you'll have to reject one of your solutions and accept the other one. Okay, so right, so this graph over here is a graph of t, and this is h. So it starts off over here, so it makes no sense for you to get a negative time. Okay, so you're gonna have to reject this value and accept this one. And at this value, both your functions will have the same height. So what is the question asking for? So let's see. How long? So the time is given to you. So question A, the answer to question A is 3.745. Okay, so this one is which is 3.745. Now for the second one, they're asking you to find the height. What height above the ground is the crate? So once you have your t-value, right, so plug in the t-value either in this function or in the other one. Both of them should give you the same h value, right? I would plug it in both of them just to be sure that I did my work correctly. But because I don't want to make this video too long, I'm just gonna plug it in my linear equation because it's much easier to calculate the answer in the linear one. So minus 5, and then I'm just gonna replace t by 3.745 plus 650, okay? And obviously this answer has to be less than 650, right? Based on the image that you have. So this is 650, this has to be less than 650. So let's work this out. Minus 5 times 3.745 plus 650. And when you do that, minus 5 times 3.745 plus 650, you get 631 0.275. And again, I think it's in meters, right? Or is it kilo? Oh no, this is a plane, so it's probably um, h is in meters. Okay, it's still in meters. So yeah, so again, you can round this off however you want, unless the question specifies it. So express your answer to the nearest meter, so 631 meters in that case. Okay, and I think that's what your textbook has. And again, right, I would plug into the quadratic function as well, and I'm gonna get something very similar to it. Okay, because again, this is not my answer, right? My time is not exactly 3.745. It's an approximation, so you might be slightly off, right? It might be 6.31 point something else um, uh, in the quadratic function maybe, but when you round it up to the nearest meter, it's going to be the same thing. Okay, so this is how you would do the question. Again, it's just a question of understanding that you're looking for the point of intersection. And again, my picture isn't very well drawn, but basically, you know, this is what the trajectory of the crate will look like. Okay, first it will be a free fall, then because of the parachute, it will slowly decrease. Okay, so you just have to understand that you're looking for the point of intersection, and you also have to understand that you're gonna have to reject this value because time cannot be negative in this situation. Okay, so with word problems, there's an additional layer of complexity because it forces you to drop one of the solutions. Okay, and when it comes to quadratic, there will be two solutions, but you'll have to reject one of them because the context will force you to do that. Okay, now you could try this question, the your turn question. It's exactly the same thing. It's given to you on page 446. And again, just one way to check your answer, one way to see if that you've done this correctly. Once you find the t-value for question A, plug the t-value in this equation and plug it in the other equation. Both of them should give you the same h value. Okay, h has to be the same, and if it is, then that means you've done this correctly. Okay, so which is basically what verify your solution means, and make sure you're rejecting one of them because of the context. Okay, so I don't really have to do this for you because you can check this by yourself. What I'm going to do is I'm going to do another question, and this is a golf one, so or baseball, I don't know. Oh yeah, it's a baseball one. Okay, so so this is the hit that Terry makes. It takes this trajectory, right? This quadratic. Again, because of gravity, right? Whenever you throw something, it will always make the shape of a parabola. So you can actually model that using a quadratic equation. And now this person is running, I think, to catch the ball. So um, so she when she jumps, right, again, because you're jumping because of gravity, it will also be a quadratic function. And basically, right, if you kind of like model this, again, you could draw this in your graphing calculator, just see what it will look like. But I'm assuming that the ball will go up and then come down, and this person is probably like jumping somewhere over here, and then this is the point of intersection, so this is where she's going to catch the ball. Okay, so this is probably what the two functions will look like. Okay, so let's solve for this algebraically. Okay, So, and obviously use your graphing calculator if you would like to get some visual support, but basically all you have to do is just use comparison. So H in red will equals to my H in blue, right? I'm just gonna remove the purple stuff over here. So this H, this is the blue one, and this is your red one. Both of them are gonna have the same height, right? For her to be able to catch the ball. Okay, um, so this one is just minus 0.1x squared plus 2x, and I'm gonna have to make this equals to minus x squared plus 39 x minus 378. Again, you can do this however you want. Okay, I am kind of lazy, so I will just probably move this over here. But when you do that, your coefficient will still be negative. And you know, students, I don't know, they don't, they sometimes make mistakes when the coefficient is negative. So maybe just because of you, I'm actually gonna move all of this stuff over there. Okay, so let's do that. So that means I need to do the opposite, right? So I'm going to do plus x squared minus 39x and then plus 378. So plus x squared, right, minus 39x and then plus 378. And then just combine your like terms together, okay? So 1 minus 0.1 will just give me 0.9 x squared. And then 2 minus 39, right? That's minus 37x, and then plus 378 is equals to 0. Okay, and as soon as you see a decimal, like automatically you should know that you're gonna have to use the quadratic formula. Okay, so in this case, x will equals to minus b plus and minus b squared minus 4ac square root divided by 2a. Again, you know, you don't have to memorize this formula, but because I've used it so many times, I know what the formula is. But remember, in your case, you were getting the memory aid. Okay, so, but on your test, I'm not gonna give you a memory aid because it's open book. So make sure you know what the formula is. So make sure you're like, you know, using your notes. Okay, when you're doing your test. So again, I'm not going to solve this because it will take me forever. So what I'm going to do is I'm just going to list down the values. So A is 0.9. Actually, I'm going to make this look a little nicer. 0.9. B is equals to minus 37. And C is equals to 378. Plug that in into your formula here. And then you're going to get 2x value. So I'm just going to use my calculator because it just directly gives me the answers. So A is 0.9, B is minus 37, and C is 378, right? So X1 happens to be 22.14, and X2 happens to be 18.96. Now, both of them seem reasonable, right? Both of them seem reasonable if you think about it, because remember so let's quickly draw the function, right? Again, you could use your graphing calculator to kind of like help you with this, but I'm assuming that the function, right, the trajectory of the ball will look like this, and the trajectory of the other person might look something like this, okay? But you see, what will happen is because the functions continue, so this is the ground, right? Technically, if your function should kind of like stop over here, but it doesn't. It continues, and then it will probably intersect again somewhere down here, okay? And it will have a negative value. So how do you know which value you have to reject? One way to so let me just get rid of this. So one way to figure out what needs to be rejected is find the h value. The h value, which will be negative, will have to get rejected. Okay, so plug in the x value in either one of the functions. So let's do that. So let me plug this. I think this would be your solution because the first, right, this one is comes before, right, the x value. This one I'm assuming is 18.96, and the other one, this one would be 22.14, right? This comes after. So the point that comes after, I will probably have to reject this because this point will give me a negative h value, okay? And let's verify that, okay? So again, you can use any function, okay? I'm just gonna use this one because it will save me some time. So let me just do that, okay? So, and then you guys can finish this off on your own. So minus 0.1, I'm going to replace x by 22.14, and I have to square that, and then plus 2 times 22.14. Okay, so when I plug that value, right, then my h value, right, this point of intersection, once I find my y value or my h value, this point, right, when I plug this x value into this function, I am getting my h value to be minus 26.88. Okay, and if you plug it in this equation, you're gonna get the same thing. And just to be sure, I'm gonna do that. So minus 1 times 22.14, then you square that, plus 39 times 22.14, and then minus 378. And that's not what I am getting. So that means I probably made a mistake. See, so you should be getting the same thing unless you've made a mistake. Okay, so I've probably made a mistake, or I've done the first question 0.1 times 22.14 squared. Maybe I didn't square it. 2 times 22.14. Okay, yeah, no. I just plugged, I think I didn't square it, so I did not make a mistake. So my y value or my h value is minus 4.7 in both cases. Okay, so this is the one that you're gonna reject. This is the one that you're gonna accept. And they're probably asking you to find so solve the system algebraically, round your answers to the nearest hundredth, which is what I've done for my x, and for the y, I think it's well, this one doesn't really matter, right? So explain the meaning of the point of intersection. What assumptions can you make? Okay, so I've kind of done that for you. Please find the y value for this one on your own. Okay, or maybe, you know what, I'm just going to do this for you. So, and I think it will be reasonable. It's not going to be too high because that person won't be able to jump that high, right? So it should be a reasonable height, 18.96. When you plug it in, you get 1.97. Okay, and which kind of makes sense, right? So 1.97, if even if you don't have a really high vertical, you can still easily attain that height, right? I think I'm like 1.72 meters. That's my height, 172 centimeters. So I only need to jump like 20 centimeters, and I think that's pretty reasonable. Okay, so again, it's a word problem, right? So it's supposed to make sense. So just ask yourself those questions. So this would be your answer, right? So after 18 meters, this person will catch the ball at a height of 1.97 meters. Okay, and this one does not make any sense because this would mean that this person, instead of landing on the ground, they would kind of like go underground and then catch the ball again um, underneath the ground, right? Which obviously doesn't make sense. So which is why you have to reject this one and accept this one, okay? So I hope this is kind of making sense. Now for your homework, I think this is a very good question. So this is about basketball. So there's a person over here. He is throwing an alley-oop, which is kind of like a pass to this guy over here who is going to, I'm assuming, dunk the ball into the basket. So the trajectory over here, I'm just going to quickly draw this, right? This person that's jumping will probably have a trajectory that looks like this, right? So let me just draw this a little nicer. So again, you can graph these functions. So this is Ben. Ben. So I'm going to be consistent with my colors, right? So this guy's trajectory is in blue, and the trajectory of the basketball, because it's an alley-oop, will probably look something like this. Okay, when you graph it. So this would be the quadratic function, and you're going to have to find this point of intersection. Okay, not this one. This would be the point of intersection that you're looking for, because remember, when you dunk the basketball, you dunk the basketball while you're going up in the air. Okay, so as your height is increasing, that's when you dunk the ball, not when you're coming down. Okay, so again, complete solution is given to you on page 449. So try doing this one because there's a lot of guidance given to you. Or you could also, this is optional, right? You could also do this question, especially for the students who are taking physics. I think you might find this question more interesting. Then the basketball one, I would honestly like, I really like the basketball question because I'm a huge LeBron fan, right? And he's very good with alley oops and stuff like that. So this really is a great question. But you know, if you're not that much into sports, maybe try doing this question. And that is it for word problems. Okay, so it's basically what we did last class. If anything, it just gives a little more life to the problems. And I think you know, it's fun um, because it shows you how powerful math can be, right? So for homework, just do either one of these two questions, and that will be it for this week. Okay, and if you have any questions, please join me during my office hours on Thursday. And for your quiz, I'm not gonna be quizzing you. On any of these concepts just yet because some students are falling behind. So I'm just going to ask you to catch up. But you will have a Google assignment to do, which will be more of a survey than anything. So I'm just going to ask you a few questions about how the class is going. And you just have to, you know, submit multiple choice answers so that I kind of have a sense of how you guys are feeling because I have this impression that some students are um, kind of running behind, and I would like to help you if that's the case. If I need to slow down a little bit, let me know. But you know, those questions will be given to you on the Google forum on Google Classroom. So please do that because it will count towards your attendance. Okay, if you don't fill that in, then I'm gonna have to mark you absent. But in terms of you know, material, this is it for this week. If you have any questions, please send me an email or join me during my office hours. Okay, so that is it, guys. Take care.